is Pre-Calc. It's problem 4-107. It's one of the classwork problems. It says to solve this. So basically, it's because this says it has to be greater than 0, they're basically wanting to know, like, where on the graph is, if I did graph this, where is it above the x-axis, or where is it positive? So we're going to end up with not just a single number for an answer, we're going to end up with an interval. So what I like to do is first get it all factored. We have x minus 1. And then I need some split points here, because remember, this is a parabola, and it's going to have some x-intercepts, and those are the places where we're going to have some asymptotes. So if I factor this, 9 times 4, let's go like this. I think it's going to be x plus 9, right? And that's equal to 0. So I'm going to go ahead and get my split point. I call them split points, my boundary points. So I know that this graph is going to cross the x-axis at 1. So that's one of my split points. I'm going to have a 1 from here. I'm going to have a negative 9, and I'm going to have a 4. So let's put those in order. Negative 9. I'm not really worried about the accuracy of this. I'm just using it as a chart. A 4. Wait, that's negative 9. A 1 and a 4. So this kind of splits my, I don't know, it splits, now there's 4 regions, 1, 2, 3, 4. There's 4 regions for me to test, because I know that this graph is, it's got some asymptotes right here, and then it crosses the axis at 1. So I'm just going to find out, where is this thing positive? Like, what intervals? Is it positive to the left of negative 9? I don't know. Let's check. Let's find a number less than negative 9, or to the left of negative 9. So I'm going to use negative 10. And I'll just write negative 10 down, just so I remember what I plugged in. So in my mind, I just go negative 10 minus 1, that makes, I don't even care that it's negative 11. I just care if it's negative or positive. It's negative. It's going to make a negative number. I'll make a little picture of my fraction. So I'm going to have a negative numerator on my fraction. If I plug negative 10 in here, that's going to give me a negative number. And if I plug negative 10 in here, that gives me another negative number. So that makes my whole polynomial into, or my whole function into, well, a negative divided by, you know, like these will make a positive. It's going to make it negative. So I'm just going to write negative over here. Usually I just write a minus sign. So this region over here, the graph is negative, because I tested negative 10. And then a lot of this I usually do in my head, but I'm just writing it down to show you. Somewhere between negative 9 and 1 is a number that would be convenient to plug in. You can pick any number that's in between negative 9 and 1. I like 0 because 0 is usually easy to do math with. So maybe I'll make another little fraction thing. So if I plug 0 in right here, I'm going to have a negative on the top, and then 0 plus 9, well, that's going to be a positive number, and a negative number. And a negative divided by negative, that's going to make this whole region is going to be positive. Put a plus. Okay, because I'm looking for the positive regions because those are the solutions. The negative ones are not solutions. They don't make this true. What's a number between 1 and 4 that I could easily use? I could use 2 or 3. Let's just use 2. And you don't have to write all these down. I'm just writing them down so I don't forget what I did, and so you can kind of see my thought process. So I just plug a 2 in there. 2 minus 1, that's going to give me some positive number. 2 plus 9, that gives me a positive number. 2 minus 4, that gives me a negative number. So we're going to have it negative in this region. And then after 4, like a number that's to the right of 4, is 5 is a nice number to use. I'll just use 5. So 5 minus 1. 5 minus 1, that's going to be a positive number. 5 plus 9, that's going to be a positive number. 5 plus 4, that's going to be a positive. So this is a positive divided by a positive is a positive. So because my original function, it wants me to solve it for where is it greater than 0. That means where is it positive. So I see there's 2 regions. So this is what's nice about interval notation. See my negative 9? I'm just going to go negative 9 and 1. And then I'm going to union that with, see how it's like it kind of goes right with my graph? I'm going to union that with 4, and I guess I have to use infinity. And I think that's the answer. I'll check and make sure it's right. See if that's right. Yeah. Maybe I'll just do one more. I'll do letter B, because this video can't be too long or else it'll cut me off. So we'll just do letter B, just so you know. This is 4-107, letter B. So I've got 8x minus x squared over x minus 6. This time we're looking for less than or equal to 0. So we want to factor so we can get our split points. So I see that I can take an x out. I'll make a little number line somewhere on my paper. So I see that I'm going to have zeros. Whenever x is 0, we're going to cross this axis. So that's going to be a split point. And then when 8 minus 8, when x is 8, and then when x, we're going to have an asymptote, a vertical asymptote at 6. Oh, I could have spread those out a little bit, couldn't I? Oh, well. And so you don't have to make the squiggly lines. I'm just doing it to emphasize I have 1, 2, 3, 4 regions that I need to check. So to the left of 0, any number, like I'm trying to think of a number that's to the left of 0. So negative 1 would be the easiest one to plug in. This time we'll do it in our brain a little bit. Negative 1, so that's going to be negative, and then we'll have positive. So it's going to make the top negative, negative 1. So that's going to be positive. I'm just going to write a big old plus, positive. Okay, and then I'm doing these in my mind this time. Okay, I'm going to pick a number between 0 and 6. 1 is a nice number, so I'm going to plug 1 in. If I plug 1 in up here, I'm going to have positive, positive. So the top will be positive, negative. So this is going to be negative right here. And you can do it in your mind, if you can, or you can make a little, maybe that's why they make the chart in the book, because maybe it's too hard to hold the numbers in your mind. If I can do it, you can do it, though, because you guys are better than me at that. So between 6 and 8, 7 is a nice number. So try to do it in our head. 7, that's going to make this positive and this positive. So we'll have a positive numerator and a positive plus. Okay, and then 9 would be a nice number to check. That to the right of 8 would be 9. So that's going to make this positive, that's going to make this negative, and this positive. And that's kind of typical. A lot of sometimes a polynomial will bump. It'll have like a double factor in it, but we can see that it isn't. But anyway, so there's regions that are positive and regions that are negative, and we have them all identified now. And then we can look back at our original problem And they want all the x values that make this function less than or equal to 0. So less than or equal to 0 means negative. So I'm just going to use these little regions right here, and I'm going to use the square, the brackets, because I've got the equal. Okay, so right in between these two. See, that's why I kind of like these things. And then I can union that with, over here, 8. But then for infinity, we use a parenthesis because we don't include the end of infinity since it doesn't have one. So I think this is right for... Now, you don't care that much about these two problems because these were your classwork problems, but hopefully that made you understand how to do the homework.